The next part is the confidence intervals. That it's very short. So we said that, I said that we have X bar plus minus margin of error, right? So this X bar plus margin of error and X bar minus margin of error, if you write down the numbers, it's going to give you a range. That range is confidence interval. So we call it confidence interval. When we say we have a confidence interval of the 95%, it means that if I get 100 different, listen to this part, we worked on that before on CHE22, but it's like that. Let me recall it for you. The meaning of the confidence interval. If I get 100 samples, 95 of them, they have the actual mean inside them. That's the meaning of the confidence interval. So 95 samples, set of samples, out of 100 set of samples, we are 100% sure that we have mean inside them. When we say 95% confidence interval. So we are 95% of the sample sets, we are pretty sure that we have the mean inside those sample sets. Here it says that the sample mean is a point estimate. Yeah, because it's a point estimate in the sample, right? As a point estimate, it has the undesirable property that we do not know how far away it might be from the population mean. So and because of that, we would like to have an estimate indicator which combines information from variability and the sample size. So the confidence interval, as I said, is such an estimate. It's like that we connect the sample at the beginning of this, of chapter 1, I talked about this. Everything that we do in our calculation, if it's just we found out the value for the sample, no one's gonna pay a penny for that to us. We need to interpolate that, and we need to make it have some interpretation for the population. So it's like that, and for that interpretation, we need the confidence interval. So it's like that we would say X bar plus minus margin of error, for example. So look at here, we want to talk about that, for example, when we find out mean, if finding out the mean is enough or not. Two companies, A and B, are producing pellets to be injected model. The plasticizing time target is 1.8 seconds. You have your choice of which company to buy from. Okay, so we know that our target is 1.8. Think about it, which one would you recommend if you just know the mean? So for company A, the mean is 1.8 and company B is 1.9. Can we say that the average of the samples, company A is better? You can pause the video, think about it 10 seconds and come back and listen to the rest of it. Hopefully your answer was no, because we don't know the variance. So let's look at the let's have more information. So 1.8, it can be from 2 samples, and 1.9, it can be from 20 samples. So now if I give you this extra information, but which one would you choose? Can you say A or B? Which one is better? And still we can't say B is better because it has the larger sample size. So we go one step further. We need to find out the standard deviation. So this one, the standard deviation is 1.41, and this one, the standard deviation is 0.11. And then we have the range. Range is the minimum value of the data points, and then you would subtract it from the maximum value of the data points. So maximum minus the minimum. For this one, the range is 2. For this one, range is 0.4. So when you look at this, to make a decision, we need more than just the mean. So now we can say that probably B is better, but still we need more information when we want to make a decision. Because based on our decision, when we want to make a model later, that model is going to have the actual effect in life, right? In other people's lives. So we are responsible for it. So the confidence interval for the mean, we would say we can construct a confidence interval about the sample mean of the X bar such that we are 95% 99.44% confident that the interval contains the true mean mu. So when you go and read in the books, different books, the way the wording is like this. I always think that stats is like, it's like different language in my opinion. So whenever you see something like, you see an example in any language, think about it, look at it in this way, that you are trying, first you need to translate that language, even it's in English or it's in French, it's in Persian, any language that is, you have to translate it to a stats language first. For example, here is 95.44% confident that the interval contains the true mean. So this one means that if I have 100 sets of sample, 95.44% of those set of samples, they have mean inside them. So we are sure that we have the mean inside them. The 95.44 confidence interval, so we want to find out is going to be x bar plus minus 2. Here, this 2, I'm going to tell you how we find it. Sigma over square root of n. So this 2 times sigma over square root of n, we call it margin of error. This 2 comes from the table. So what do we need to do is that here is 95.44. So we need to find out the alpha for it. And then from the table, we will try to find out the value, the z value for it. So if you go, you will see that it's going to be 2. 99.74% confidence interval would be, so if you go and read the z table, the value of the z for it is going to be 3 times sigma over square root of n. So what are you going to do for finding out this one? This is just a rule of thumb that we know, but how can you connect it is that you say 1 minus 99.74, whatever value that you found for the probability, go back to z table and read the z value for it. You will see it's going to be 3. And then for the 2 companies that we had, A and B, from the previous page, assume the standard deviations are the values of the sigma. And then we would say company A is like 1.8 plus minus 2 times 1.41. Like it's like that you would say sigma, right? The sigma for the company A divided by square root of n, and n sample size was 2. And here is the 1.9 plus minus 2, and then sigma, which was 0.11 over square root of n, n was 20. And we can see that here for company A, the interval is minus 0.19 and 3.79. It has negative, which is a red flag here somehow, but we don't have negative number here in this example. We can't have. And then 1.85 and 1.95. So you can see that here we can say, oh, company B is better because we said that the average should be, like the target is 1.8, right? So you can see that how close to the 1.8 we are here. But here you see that how big is like that. Here it says that we have the, we are looking for the 2, right? 95.44% from the sample sets that we get. It's going to be between these, like mu, the real mu is going to be among this number. But here, the 95.44% of the sample sets that we have, their mu is going to be in this range, which is very close to the target. So now we can say company B is better than company A. And here's the distribution that we have. So for example, for the x and mu and sigma 2, if it's for x, it's going to be like this. For x bar, it's going to be n. Mu is mu, but for like expected value for x bar is going to be mu as well, right? But the variance is going to be sigma 2 over n. Be careful with this one. It's different. So here we are interested on x, but here we are interested on the x bar. So here is another things about the confidence intervals that we want to, like, we are continuing talking about the confidence interval. Okay, so with the confidence interval, it's like that. We say an estimate of a statistic plus minus a multiplier times the standard deviation of the estimate of the statistic. So this is the general equation that we have for the confidence interval. Because we said that it's like 2 times sigma over a square root of n. That 2 is the, like we have the x, I said that x bar plus minus this one. So x bar is the estimate of a statistic as it's written here, plus minus. A multiplier is going to be z value or t value here. Here is going to be z because we are looking for case 1. I'm going to write down case 1 here just as a reminder. So it's going to be, and then so later I'm going to like expand this so you would see that. So let's say we are looking for the case 1. We said that we have 4 cases, and I use this term of the cases a lot while we are working together. So case 1 is that the parameter of interest is mu, and sigma 2 is known. So when we have case 1, we are working with the z table. So when I go to the next slide, I will remove the share screening part, so you will see just the board. But now let's just, it's a good time to write it down on the board that I will remember it later to talk about it. So we are looking for the general, that's the general guiding formula for a confidence interval. So that multiplier, if it's case 1, it's going to be z. If it's case 2, it's going to be t. If it's case 4, again, it's going to be z. If it's case 3, we are interested in the variance, so we go to another method, and it's going to, the multiplier comes from the chi-square method. So confidence interval on a population characteristic, so it's like that, whatever comment that we make from the confidence interval, in fact, we are talking about the population. It's like we are interpreting something from the sample for the population. And the multiplier takes into account some level of significance. It means that, so if you want to read the multiplier from the table, so you need to know the alpha, and alpha comes from the confidence interval. Like, for example, if my confidence interval is 95%, alpha is going to be 5%. Next page is an example. So what are the multiplier for exactly 90, 95, and 95% confidence interval? And we are thinking that we are working with the z table. So it says check z table. It means that we are in the case 1. So we have the population. We're interested to find out the mu of the population, and we know the sigma of the population. So we are going to work with the z table. I draw this table on the board so I can show it to you and work on that on the board with you. So look at here. It's like that. The confidence level is 90%, 95%, 99%. So what do we need? And let's say we are working in the two-sided case. So two-sided. So when you go and review the second year stat, you will see that we have two-sided and one-sided. When it's two-sided, it means that this 90%, the alpha is 10%, but when we want to read it from the table, we need to read the data for the half of the alpha, which is going to be like 5% here. So what are you going to do is that we would go to the z table, and for the z table here, the half of the alpha from here, the half of the alpha is going to be 0.05. So for 0.05, we will see what's going to be the z value. So this factor is in fact the same as the z value. I'm going to just write down z. So it's going to be the z value. From the table, read the z value for 0.05. You will see it's going to be 1.645. So for 95%, it means that half of the alpha is going to be 0.025. So the z value is 1.96. And then for the 99%, half of the alpha is going to be, we are looking, so it's like that you're going to try to find out what's going to be the, this one is 0.005. So what's going to be the z value for the half of the alpha, because we said it's a two-sided test. If you want to look at it like on the curve, it's like this. When it's two-sided, it's like that. I have the confidence interval. Here is mu. I have the confidence interval for this range. So if I say that my confidence interval is 95%, so it means that half of like 0.025% is here, and 0.05. So this is going to be alpha. So half of the alpha. I would say this is the half of alpha. This is the another half of the alpha. So for two-sided. If it was for one-sided, it meant that we are going to have all of the alpha in one side. It would be, we have for the one-sided, we are going to have left and right. So it's going to be the same thing. So we will go to the z table and read the z value for it. So now let's say I have the z value. How can I write down the confidence interval for it? So you can pause the video here, try to write down the range of the confidence interval for yourself, and then come back and look at the rest of it. So for this one, it's going to be x bar plus minus whatever value that I have for z, 1.645, right? And then the standard error. The standard error for case one, if you go to the summary, even if you didn't have time to look at the notes of the CHE 220, I would recommend that at least you would look at the summary of them, because if you go to the summary of chapter 8 or 7, you will see these ones as the cases. So in case 1, the standard error is going to be sigma over square root of n. So we will have the, if it was case 2, we are going to read it in like in 1 or 2 slides. This one would be t, we would need to do the same things, but find out the t value, and then here is the sigma over square root of n, it would be s over square root of n. So this is going to be the CI. So let's have here CI. And for this one, it's going to be x bar plus minus 1.96 sigma over square root of n. And for this one, it's going to be x bar plus minus 2.58 sigma over square root of n. And you can see that when the confidence interval is larger, when it's 99%, it means that this one is going to be wider as well, right? And you can see here is 2.58 times something. So it's the x bar plus a larger number comparing to this one, greater value comparing to this number. So this is how we would write it down. Or you can write down like x bar, this plus minus. You can write down x bar and use the equality, inequality sign for it. Say that x bar is between this positive value and the negative value. So that's for the an example for the confidence interval. So the next slide, let me just share the. Okay, so we worked on this. So here is what do we mean by the word confidence? I talked about that. It's like that for a 95% confidence interval, on repeated sampling from the population, 95% of the numerical intervals generated are expected to contain mu. It's like that when you look at this, let's say this line, this vertical line is mu. So it's like that if I have, so if I ask you what's the confidence interval for this one, what would you say? What's the value of the confidence interval for this? You can pause the video and think about it quickly. So each of these are representing one set of sample. And you can see that this one, this one, and this one, and this one, they have their mean inside them. So if I show you something like this and tell you, give me the like value, the percentage of the confidence interval, what would you say? Pause the video and think 10 seconds, and then come back and listen, look at the rest of it. For this one, it's like that we have 5 samples, 1, 2, 3, 4, 5, yeah. 5 samples, and 4 of them, they have the mean inside them, and 1 of them, they don't, it doesn't have it. So it's like 4 out of 5, or 80%. So we would say it's 80% CI. So we would write like, we would make comment like this. Try to understand the meaning, the conceptual meaning of the confidence interval. It's going to help us a lot later when we are working, when we want to make judgment on the design of the experiments, even in the surface modeling. So there are some, these are remarks about the confidence interval. So we said that we have one-sided and the two-sided. The approach assumes no systematic error, that we don't have any systematic error. And then for the two-sided and one-sided, we have two-sided and one-sided, as we said. The confidence interval could be made narrower by decreasing the confidence level. So in this example, we talked about that, right? So here, we will see that when it's like that, we can make it narrower or wider by the by playing with the amount of the confidence level from the, like, for example, from the 95%, from 90 we went to the 99, so we made it like wider. The population mean mu is constant, is fixed, is the expected value, right, for the mean. The interval changes from sample to sample. Probability is based on the distribution of the X bar, not on the individual observation on X. The distribution of X bar approaches the normal distribution according to the central limit theorem as n increases. So in fact, with the central limit theorem, we are going to find out this equation. And when we want to, like, X bar plus minus Z times sigma over square root of n. If you want to play with it, you can do something like this. Say that Z is equal to X minus mu divided by sigma. And then try to, we have the proof of it in the CHE 220 notes, but you can simply say that, okay, so you want to find out the range for X, right? So that's what, this is the X bar. So when we want to find out the range for the X bar, you would say Z for the X bar is going to be equal to X bar minus mu divided by the sigma over the square root of n, because the standard error or a standard deviation is the same. For the X bar, it's sigma over a square